Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on January 11th, 2026, about 3 days ago. It introduces a framework that transforms chaotic GitHub data into structured memories, boosting the success rate of coding agents on the SWE bench verified benchmark by nearly 5%. The paper is titled, MemGovern, Enhancing Code Agents Through Learning from Governed Human Experiences. And, as we'll see later, this method allows models to stop reinventing the wheel and instead learn directly from past human developers. And for those interested in the implementation, the authors have shared their code on GitHub. Alright, Figure 1 breaks down these performance gains across 8 different large language models. It compares the baseline SWE agent in gray against the MemGovern enhanced version in blue. Consistently, the blue bars are higher, meaning the memory framework helps every model tested. While top models like Claude 4 Sonnet and GPT-5 Medium maintain the lead, others see massive jumps. For instance, Qwen 3 improves by roughly 8 points, and GPT-4o gains nearly 10 points. So, Figure 2 illustrates the core workflow difference. In the top panel, existing methods typically rely on raw trajectory experience, or unstructured search, which often leads to failure because the information is noisy and disorganized. MemGovern, shown in the bottom panel, changes this with a two-step approach. First, it runs an offline memory refinement phase, where raw GitHub data is standardized into clean experience cards. Then, the agent uses specialized search and browse tools to access this curated database, allowing it to apply human-like guidance to successfully fix the bug. Well, Figure 3 details the complete architecture. On the left, the process starts with hierarchical experience selection, which filters noisy GitHub data down to high-quality issues and patches. The center panel displays the resulting experience card, which is key because it splits information into 2 parts, an index layer for efficient searching, and a deep resolution layer containing the actual root cause and fix strategy. This separation enables the workflow on the right. Here, the agent first performs a similarity search against the index to find relevant cases, and then browses the detailed resolution layer to retrieve the specific knowledge needed to fix its current bug. Okay. Table 1 provides the hard numbers behind those performance claims. The top section lists other baselines like Autocode Rover and Codact, establishing the competitive landscape. The bottom section is the main event, pitting MemGovern directly against the standard SWE agent across 7 different backbones. We see consistent gains everywhere. Notably, GPT-4o jumps by 9.4%, and Qwen 3 gains over 8%. The last 2 columns show a slight increase in token usage and cost, but the authors argue this small overhead is well worth the significant boost in bug-fixing ability. Alright, Figure 9 brings this to life with a case study on a Django formatting bug. On the left, the standard retrieval augmented generation approach fails because it retrieves experiences based solely on surface keywords, getting confused by irrelevant front-end issues like text alignment. In contrast, the right side shows MemGovern's agentic search. Here, the agent first retrieves a candidate list, and then actively browses the specific content of the most promising ones. This extra verification step filters out the noise, leading the agent to the correct back-end solution. So, having seen the workflow, Figure 11 now zooms in on the exact blueprint of these experience cards. It lists the schema that transforms messy GitHub issues into actionable memory. The top fields, problem summary and signals, act as an index, allowing agents to match bugs by symptoms. Then, the root cause and fix strategy sections capture the reasoning behind the solution, so the agent understands the design logic. Finally, the patch digest and verification fields provide concrete code summaries and test plans to validate the repair. Wrapping up, MemGovern demonstrates that structured memory is essential for unlocking open-world knowledge. By organizing chaotic GitHub data into governed experience cards, it allows agents to solve complex bugs by truly learning from past human expertise. This implies that future gains will rely heavily on robust memory infrastructure. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.